Hi there, I'm Anton. Thanks for choosing to watch this video. In this video I'll show you how to program this six-legged walker here. I call her ladybug, and we're going to use keyframe animation to do this. It's a concept from movie animation and video animation, and I'm going to show you how to do this on robots. So keep watching if you want to learn how to do this with your own robots. Even if you don't have this robot, it can still be very interesting. Maybe you have a similar robot. I think I should probably explain the concept of keyframes to you first, and that is best done by going to Apple Motion. Apple Motion is a video animation program, and it's the one that I use to animate my logo. And here you can see there are little red beams on the screen, and the red beams, they rotate during the logo animation. You can see them all rotate, and this rotation is created by these two keyframes at the bottom. So the rotation starts here at about 50 degrees, and then they rotate, and they move up all the way to exactly 600 degrees. So they turn more or less 2 revolutions during this very short time frame here. And so these two keyframes, starting from angle 0 to angle 600, they define the complete motion of the beams. And then of course there are different keyframes that control the distance from the red beams to the center, and that's more of a curve. But for now it's interesting to note that this continuous rotation at a constant speed needs only 2 keyframes and a linear function. So that's the same thing that we are going to do with the robot. Okay, let's get to it. So first I'm going to connect this one to my MacBook with Bluetooth and start a new project. Okay, I'm in the Spike Prime interface here, making a new project. We're going to use Python, so creating a Python project here, and press connect to Bluetooth. So connecting here to Bluetooth. While we're waiting here is a good moment to subscribe if you're interested in more tutorial videos about programming complex robots like this one. Yeah, complex. Well, it's got 6 legs and all the motors have to work in sync. Now, we're connected. The green line is the green light here is blinking, and I'm seeing all my motors. And the first thing I'm going to do is actually remove all the code that's already in here and use a starter code from my website, which does all of the heavy lifting with keyframe animation. And the only thing we are going to add in this video are timings and positions for the motors. Okay, let's go here. And so on my website you will find Spike Prime tutorials, and there is the keyframe animation article. And so if you're interested in the background of how it works, you can read the article. If you just want to get started with this, you can download or get the code here on GitHub. Scrolling down, and all of this is I'm also going to put the link to this code in a card top right of the screen and in the description below. Okay, so copy all of this basic code and paste it here into the project. The code has got a header here that we can change. So this code animates ladybug, and the real thing starts down at line 320. So I wish all of that code could be hidden and you could just import all of the basic code that I created, but alas, in the current software you cannot do multi-file projects, so we can only like paste all this and then scroll down until we have boilerplate control loop, and this is where the magic happens. We can start to define keyframes for the outer legs. Maybe I should probably so outer legs, and I think I should show you something on the model how this works. So this ladybug model here has got outer legs, so the outer legs, those are these on the right side and the left side, and they move forward and backward using this motor, and the legs on the other side move using that motor, so they are always connected, the outer legs. And the challenge here is going to be to move those legs in sync, so that whenever this leg is forward, that leg goes backward and vice versa. And we'll do that first, and once that's done, we're going to use to program this motor, and this motor tilts the ladybug from side to side. So I'm going to try and tilt it here. Once it is tilted, so it lowers this leg, this means that these legs lose traction and can move freely, and those legs here, they drag the ladybug forward if we time all of these movements right. So our challenge here is going to come up with keyframes for all legs, and then animate them and synchronize them so the ladybug here starts moving. Back to the Spike Prime software. So first we define a set of keyframes for the outer legs here. I should put the equal sign. So in Python, things between square brackets are lists, and you don't have to put the list all on one line. So I can open the brackets and then put the first item in the list on the next line. This makes the layout easier. And at time 0, I want the position to be 0. That's fine. And then so this is my next item in the list, so I'm adding a comma here, and the next keyframe in the list is going to be another combination of time. So let's say 2 seconds, that's 2000 milliseconds. I want the outer legs to have run exactly 1 revolution, so that's 360 degrees. And then here my list is closed again, and that's, yeah, I could put that there, I could put that there. I think the layout looks better like this. And then we're also going to do the middle legs keyframes. Same thing, so I could put everything on a line here. I want them to be at 0 at time 0 too, and actually I'll just wait to animate them and leave them at 0 all the way, so even when 2 seconds have elapsed, they still will be 0. But this is my list with 2 items, and to make this one easier to read, I'm going to add some new lines here. So my list is an easy to read vertical list of items. You can even, if you like, add more spaces there, so these numbers are aligned. It all doesn't matter in Python. Now we have keyframes. That was pretty easy, like the little red beam. And so next thing is going to be defining the motors. That's a list too. So let's say hub.port.a.motor And what other motor do we have here? B hub.port.b.motor. So these two motors are moving the outer legs, and then there is a hub.port.d.motor that is moving the middle legs. Now we have our keyframes, our motors, and then finally we are going to connect these motors to the keyframes with a linear interpolation function. So it's all in the code up here. I probably should enlarge this a bit so it's easier to read on YouTube. It's all in the code up there. So this linear interpolation makes sure that when you are at a certain point in time, it creates the exact, it actually calculates the exact angle that where the motor should be when these two keyframes are defined. So these motor functions are a list with the same length as the motors, and they are also in the same order. So for motor A, we're just going to use the outer legs keyframes. For motor B, that's the same. So I'm going to copy and paste this. And for motor D, so that's the third motor here, we are going to use the middle legs, which actually will not move the motor at all because the keyframes remain at 0. And this should actually be enough, because the boilerplate code then goes on to define a mechanism with these motors and the motor functions. It resets the mechanism, so all the motors go to their 0 positions, and it starts a timer, and then it has a while loop. So for 10 seconds, 10,000 milliseconds, it will update the motor powers according to the keyframes, and it will sleep a little bit in between to give the spike hub to some time to do some background processes. After these 10 seconds, it will stop all motors and stop the program. Let's see how that works on the model. Probably should lift the model here. Okay, we have a pretty neat animation here. So the legs are moving, and I didn't even have to invert the movement for left and right legs, because the motors here are mounted in a mirror fashion. So even if I let them turn in the same direction, they will actually in reality turn in opposite direction because they are mirrored around on the model. So the outer leg movement is already right. Now the next thing to do is program the inner leg movement. Okay, so if you move the legs to one side, actually the first side where it has to be, you can see now here on motor D about 120 degrees. Show you on the model. So now these are lowered and these legs are lifted, and that's enough. Could even be a bit more. 150 is enough to lift it. So if motor D would just start there at 150, would that be right? Yeah, I think let's 140. Start easy, and then one is coming apart here, and then about so the outer legs move forward and backward a full cycle, and so they start centered and they will be fully forward after a quarter of the period. Probably it's easier if I define the cycle time here. So the cycle time, let's set that to 2000 milliseconds, and then replace this one with my constant cycle time, so I can later speed it up or slow it down. So what I can say is that I'm starting at 140, and then let's say about 20% in, so that's cycle time multiplied by 20%, 0.02. We still want to be at 140, and then let's copy this keyframe and take, I don't know, about 100 milliseconds or 150 milliseconds to switch sides all the way over to minus 140, and let's keep that position of minus 140 about half a cycle, so all the way up to 0.70% of the cycle time. And at that point take so let's go over here, 70%, take another 150 milliseconds to switch back to 140, and then let's keep this 140 all the way to the end of the cycle here. So this these keyframes tell the middle legs to move to one side until the one set of legs is almost forward. Then take 150 milliseconds to switch to the other side. Give the legs time to switch positions and switch back to its original position. So let's see if we have programmed this right, and if we have guessed the angles right here. That's always a question. Okay, switching back over to the model. Oh no, it's moving backwards. So let's go over here, change every plus to minus and every minus to plus. Okay, so we end at the same position as we start. Let's try this one again. Okay, while the program is booting is a good moment to subscribe. We still did something wrong. Let's see how we can debug that. Ah, I found the bug. Somehow one of the legs got detached. So it's important, I don't know if you can see it, that the motor D here, the little gray stripe is centered when you build the model. And let's try that again. Aha, this is more like it. Okay, so now we have all the keyframes right for a 10-second ladybug walk, and now we can start to do fun things, making it walk backward, and actually also using the distance sensor here to detect obstacles. So let's try and do that in the current code. So first, I think the easiest thing is to make it walk backward, and we can do that easily by reversing time. So here we define a timer, and then it's running until it goes over 10 seconds, and then everything stops. What we can do is copy all of this, run it again, but we are going to reverse the timer. So let's go timer.reverse, and we are going to let time run backwards. Then of course it counts down from 10,000 to 0, so we don't wait for time to be less than 10,000, we just wait until time goes below 0. So we run this loop as long as time is above 0, and we are going to update the mechanism again. So if all's well, the robot will now walk forward for 10 seconds and then backward for 10 seconds. Let's see if that works. Okay, that's the forward cycle, exactly as advertised. And oh, the robot is coming apart. And the backward cycle. So you can see that the model runs backward here without changing any motor parameters. We only let time run backward. So we've run the motor forward and backward, and now it could be interesting to make the motor turn. So let's leave all of this here, and to make the motor turn, the only thing we have to do is actually reverse one of the legs. So if we scale all of the was it scale Y? I don't know. What does it say? Linear interpolation here. Scale. So you can see here in the definition all the parameters that you can pass. It only needs keyframes to run, but you can also make sure that it doesn't wrap. Right now it's an infinite animation, and you can also scale the angle values here. The scale is 1 by default, but if we use a -1 for a scale, it will reverse all angles, so effectively making the motor run backward. So if we make one of the legs run reversed, the model will start to turn. So if all's well, this code, by just reversing one pair of legs, will turn the model left and then right for a spell. Let's see if that works. Nice. It was actually right and then left. Okay, and we can remember this by actually dubbing these motor functions turn left and copying them, remove this and that. But those were our original walking functions. So this is a short video here to demonstrate. Okay, so this is this was a quick explanation on how to animate robots with keyframes, and I hope you see that this keyframe system isn't only relevant for this ladybug, but actually applies to a lot of different models. If you do want to play around with this model, however, I put the building instructions in a card in the top right hand of the screen here. So I'm selling the building instructions for this model on my website to cover a bit for the cost of the recording equipment and all the time that I put into these videos. So by actually buying and downloading these instructions, you can also support me and my channel. Thanks a lot in advance. If remember, if you do have any questions about the programming of this one, be sure to ask them below in the comments. Thanks for watching. See you. Bye bye.